All right. Good morning, everyone. I have here the graded assignment. I'm not sure how we should distribute it, maybe after the class. We are going to have a review session in case someone have any question of the grade with the TA. So hopefully, I think Naeem will be back tomorrow. Hopefully Wednesday or Thursday, we'll have the review session over Zoom. Okay. We're going to have it for about 2 hours. So in case it doesn't fit in one time, you can join later on and so on. Right? And most likely we'll have the other assignment on next Wednesday, as we agreed last time. Okay. So it will be in class during the last 30 minutes or so. Okay. So we will cover lecture 8, I think not 8, 7, 6, and 5. Okay. 7, 6, and 5. For those who couldn't make the first one, we'll be covering everything until lecture 7. Okay. Which is mostly chapter 1. Chapter 2 won't be included in the assignment. All right. So continue with the chapter 2. This is extremely important topic. This is where we are going to optimize the Boolean equation. So last time we take 2 methods in order to extract Boolean equation from any truth table. Okay. Today we'll continue to optimize this equation. So remember, we're still covering this book, the first one. Feel free to visit any of those. We are currently in chapter 2. And we're still with the story of the compute stack. We move to the logic gates. We are currently still in the logic. And last time we covered 2 important methods. Please focus around these 2 methods. Try to practice it. We have a lot of questions in the book. Please go try to solve them. You have the answer as well somewhere online. I already provided the link to the book, to the lecture, to the slides, to the solution in the first lecture. In case you miss it, just go back to the recording. You'll see a direct link to this material. Okay. How many of you have the book already? Soft copy, hard copy?
Virtual.
Yeah. Okay. How many of you read it? Did you check questions? Okay. Yeah, please do so. It will be really important for you. So last time we covered 2 important methods. One of them called sum of products, and the other one product of sum. Okay. Do you have any questions about those? Any question? Is it clear? Okay. Let's take some examples to make sure it's clear. I have a question for you. You are going to the cafeteria for lunch. You won't eat lunch. Okay. If so, this only satisfied if any of those 2 conditions are met. If it is not clean, that's one. Or this is extremely important. Or if they only serve meatloaf. Now, we have 2 conditions, and if any of them met, meaning that any of them satisfied, then we are not going to have lunch. Okay? Now, write the truth table for determining if you will eat a lunch. Now, what is the input? What is the output in this case? Yes, please. C and M are inputs.
Or E is the output.
C is the output.
No, C and M are inputs, E is the output.
Okay, let's see. Do you agree? Do we have any other opinion? No, okay. Now for E, we consider it as eating lunch, right? Can we consider it as not eating lunch? Likewise, it's not clean. Can we consider when it's clean, then C is something? So we have to really pay attention to these details. The truth table can be different if we assume the meaning of that variable is something else. Okay, yes, please, Al.
Would it be easier to just extract it out to like we and then 0 1 or not? That's is there like a standard?
100% correct. 100% correct. Nobody can argue with that. But you have to emphasize it whenever you solve this question. You have to make it clear that this is what I mean by this variable being 0 or 1. Okay, this is extremely important. So there is no one solution for this. It really depends on how you interpret those variables. If you interpret E as eating lunch or as not eating lunch, then the meaning will be different. So we'll have the opposite story. So for here, the question already given you that you have to consider E equals 0 when not eating lunch. So you cannot assume the opposite. So it's 100% clear in this question that E equals 0, not eating lunch. E equal 1 means eating lunch, okay? Likewise for those two inputs. So how many input do we have? 2, right? Okay. And what is our method in building truth table when we have 2 input?
Start from the right.
What is the first input?
0.
No, what is the name of the variable?
Oh, the first one is C.
C,
Second one is M.
M. All right, excellent. And then we have vertical line separating the input from the output, right? What is the output?
E.
E. How many output we have? 1. Perfect. Now for the input, you don't have to think about it right away. Where should we start? This column or this? Right one. How we should start? 0, then 1, then 0, 1. Should we continue?
No.
Maybe. Let's see. Just stop here and you'll see later on. Or C?
0.
0, 0.
1.
Amazing. Did we arrive to a point where the entire row is 1s? Yes. Stop here. Done. Okay, don't continue. If you do this, you'll never do any mistake. You'll not forget any possible option. Now for the E, it's a bit tricky because you need to pay attention to the question and try to interpret how you calculate. Question says E equals 0. E equals 0 when it's not clean, C0, or M equal 1. So let's look at the first. Remember, it's or here. It's really important to pay attention to the detail. Or will make big difference here. Is it 0? Yes, directly E equals 0. Is it 0?
Yes.
Directly E equals 0. Is it 0? No. Okay. Now let's go to the second condition. Why we are doing this? We check only C because we have or. If it is and, then different story. Okay. Now C is not 0. Let's check the second variable. M, is it 1? No. Okay. Then this is 1. Now this is not 0. Is this 1? Yes. Yes, please.
I know it says it's 4, but the way it's like, the way it sounded and the way you're like, writing the truth table, it feels like it's more of an and condition than more.
So if this and, then only at this situation it will be 1.
Zero.
Would it be 0?
0, sorry. And the rest will be 1.
What if the third one being 0 as well?
Because it is and, mean if C equals 0 and M equal 1, which is only in this case. Do you agree? Right? So we have to really pay attention to the little details that will make big difference. Now it says or, means whenever C equals 0, directly it's done. We meet the condition, right? Which is in these two cases, or M equals 1 over here. So in this case, this case, in this case, we meet one of the two conditions, then E equals 0 directly. Now again, remember, the interpretation of the meaning when it's 0 and it's 1 can be totally different depending on which one you choose. If you choose E equals 0 to eat lunch, now we have to take the opposite. If we consider it as equal ones, eating lunch, then we have to do a different truth table. Good? Yes, please.
Professor, so if the question already states that not eating is equal 0, can I change it and make eating equal to 0?
No, in this question is given to you.
Oh.
If you assume, I can consider it correct, but like why? There's no point. If it's not clear yet, please make your assumption. Right? Good? So I asked Gemini to generate a picture for that. It was really nice. But I don't know, it sounds like he already eat lunch. So this is the only mistake I found in the picture. But at least it's really describing the situation. Right? So this is the truth table. Let's compare it. Any question about truth table? Hopefully it's really easy for you, at least the input side. I hope really to not see any mistake. It's really straightforward. All right. Now, if I give you this truth table and I ask you which form you would use to extract a Boolean equation. Remember, we have two forms, sum of products or product of sums. Which one you will use based on this truth table?
Sum of products,
And why?
because we only have 1, so we'll just have 1
Excellent
equation.
I think I forgot the bars. How was the new bars? Better than the previous ones? And I'll give you the choice instead of the first. Thanks. All right. I'm trying to bring only the organic bars with no chemicals in it. Remember to take attendance for today, please. So last time we said we have two forms. One of them is beneficial when we have less ones in the output. The other one is beneficial when we have less zeros in the output. Okay? So you have the choice, logical choice to choose which one of them. And it makes sense because one of them rely on how many ones we have over there. If we have too many ones, then your equation will be very long. Then it will be extremely hard for you to optimize it. You spend a lot of time in optimizing it. So if I dedicate like 5 minutes for the question and you spend more, then you already know the reason why you're spending more time in an easy question. For example, you consider the 0, and you have 3 terms in your equation. And then you spend a little bit more effort to optimize that equation. Let's see the difference now. All right, so I copied the truth table in 2 places, and let's apply these 2 forms, okay? The first one, sum of product. Do you remember what is it? If you forget, just go back to the name. Sum of products. What does it mean? means you build products first, products, and then you take the summation of those products. As easy as that. If you want to build products for those, which we call it each of them as min term. And remember, min term is a unique to each row. Okay? And we never look at the output. We always look at the input. So for any truth table, should all the time, all those min term be the same, exactly the same. It doesn't change based on the question because we always rely on input, not the output. Okay? The only thing will be different is the variable name itself. From question to question can be different. Sometimes A, B, C, sometimes X, W, Y, Z, and so on. Okay? Now let's take the first min term. Remember, this is product, and we have two inputs, C and M. So what would be the first product? If you forgot, just go with C, M. Excellent. And then repeat it 4 times. Let's populate it. These will be the min term. Okay? However, there's one condition, that each of the min terms should result in 1. Okay? 1. So for the first row, we have 0, 0. Let's substitute over here. 0 times 0, 0. So it's not resulting in a 1. How we would convert into resulting in a 1? We need to flip the zeros. So now if we try C with 0, M with 0, 0 would be 1, M would be 1, right? Because we have bar. And then 1 times 1 is 1. Done. We're done with the first min term. Second min term, 0 and 1. So whenever we look for 0, we should flip it in order to have a result as a 1. Now, likewise here, 1 and 0. So where's the 0? At the M side. Bar, then 1 times 1 is already 1. So those are the min terms. Okay? Remember, sum of product. That's why we have a product over here. It's a dot. And last time we said when we don't see anything, it means by default a dot or multiplication. Okay? But if we see a plus sign, then this is addition. All right? Then what's next? Where's the Boolean equation? Where's the Boolean equation? We already built the min term. What's next?
So if I compare which one is going to be the output, that's 1.
Then we need to look at the output. Excellent. Which value? 0 or 1?
1.
1 or 0? 1. This one is the only one providing an output of value 1. Okay, so we take this min term, and that would be our equation. Okay, then how we represent it?
F of and E equals
E equals, right,
summation
F of C and M, which is, in this case, this min term, right? C M bar. What is the other alternative representation for this?
summation.
Excellent. Sum of product. So we add equal sum. This is summation sign. And then the index of the min term. Remember, we start from 0 here. 1, 2, 3. So the index of this guy is 2. Right? Any question on this? Okay, perfect. Let's go with the second one. Now we will build product of sums. Product of sums. Okay? Product of sums. What does it mean? So we build sums, right? Sums, different sums, and we take the product of these sums term, or what we call as a max term. So since we said sums, then we have to build something like that. C plus M, C plus M, C plus M, C plus M. Those are the sums, right? And then we take product of them. Now, each of those max term should result in 0, the opposite of those. Here we said each of them should result in 1. Now here should result in 0. Remember, each of them should be unique to a row. Now for the first one to result in a 0, so C over here, based on what we have, C is equal 0, M equals 0. So if we substitute here 0 plus 0 is 0, then it's ready for us. We don't need to change anything. The second thing, C is equal 0, M equal 1, right? So 0 plus 1 is 1. Then strong. We need to do something in order to have a result as 0. Should we add a bar here or here? On the M, right? Because the result should be 0. So now M is 1. M bar will be 0. Then 0 plus 0 equals 0. Over here, 1 and 0. So C is 1. Flip it into 0 to be 0 plus 0 equals 0. And here 1, 1, we need to flip both of them. And then the result will be 0. All right, so we build now the max term. What should we do next? Look at the output and whenever it's 0, take the max term. So the equation would be E equals a function of C and M. And based on the zeros, we have 3 max terms. We have C plus M. Remember, we are doing product of sum, so we will take the sums and then multiply them with each other. So the second one would be this guy. So we have C plus M bar. There's a product. And then the last term, whenever there's a 0, we'll take this one. Or we can represent it as a multiplication. I don't know if you can see last line. Maybe you can have it here. And then the index of the those max term. So this is index 0, 1, 2, 3. So which one we choose? 0 and 1, 0, 1, and the last one 3. So these are different terms that represent the Boolean equation. We have this or that. Okay. Likewise, in here we have this or this. Remember, it's called sum of product, so that's why we use sum symbol over there, and this one product of sum, so we use this symbol to replace this one. Okay. Now, in case you are in doubt, you already have this in the slides. Okay. So compare this with that. No mistakes, all correct. All right. So if I give you the question without asking you like which form to use and ask you just to build the Boolean equation, which method you would use? Sum of product, right? Why? Because it results in a single term that's easy to optimize later on or easy to build. Here, how many gates we require? So there's a multiplication and the NOT. And you need only 2 logic gates to build your circuit. As simple as that. But over here, if you want to build it, how many gates you need? There is or. There is not. So 3 NOTs, 3 OR, and you have the multiplication over here. Okay? So you can imagine the difference in the solution or in building the circuit itself. So please practice this very well. It's a really important topic, and this is widely used in optimizing the logic circuit. Okay, this is the very first step, just to extract the Boolean equation. There's no optimization yet. Hopefully, we'll go in the next few minutes in how we optimize it. But this is the very first step. If you do a bad job over here, done. you'll spend a huge amount of time just trying to optimize a large number of terms. Over here, you already done it in one shot. In the same amount of work, you get only one term. Over here, 3 terms in your equation. Okay? All right. Let's see an example now, another one. And remember to take attendance, please. But we will try it in 2 methods. The first one, we'll try to build it using those sums or those forms, right? And then the second method, we'll try to logically look at the question and try to extract the equation. Okay? Without doing any truth table. We'll see that. We will go to the park, P is the output, if it is not raining, and we have sandwiches. So what is the input? What is the output? R and S. Excellent. Cookie or peanut? Alex? You answered twice, right? Done. You already got one. All right. Yeah, please keep participating. This course without participating will be really difficult. All right. So we'll look at the input. So we have, you want R or S first? Okay, R. So these are 2 input. We split the input from the output to make it easy for us. And then the output, P, right? Okay. So we start from S or R? S, excellent. So we said, we just alternate. How many of them? We don't know. Okay, you just write 4. Let's see later on. 0, 0, 1, 1. Last row ends with all ones, done. Then we stop here, okay? Now we could know in advance how many rows we would need. If 2 input is 4, if 1 is 2, and so on. If it's 3, 8, and keep doing because it's binary, so it's easy for us to know. But if you don't know, that's fine. You can start with something and then fill as much as you can, and you'll see the last row is filled with ones. Now, what the question says? We will go. It's not like we will not go. We will go to the park. So we want to consider as P as 1. If it is not raining, if it is not raining, okay? So this is not raining. And then park will be 1. Do we have or and? We have and. Now different story. So 2 conditions must met. So raining, it's not raining, and we have sandwiches. So when R equals 0 and S equals 0, or no, S should be 1, right? Because we have sandwiches.
Yes.
Then we will have, I'm not sure if you can see, then P will be 1. Right? This is the interpretation of the question. If not raining, raining equals 0, not raining, and sandwiches enable 1, we have sandwiches, then park equals, right? Remember, there is and, not or. Then where do we have this situation? 0 and 1 over here. One of them. Do we have something else? No. So only this one is 1. Rest are 0. Right? Yeah, please be careful with the question, with the interpretation. This is extremely important. All right. Now, which form you would use? Why? Only 1. Excellent. The golden bar. When we have list number of 1s, go directly with sum of product. When we have list number of 0s in the output, not in the input. Don't look at the input. The input, we just use it to build the min-term, max term. But when you want to decide which form, look at the output. Now the ones are less than the 0, then directly go with the first form. Okay? Now let's go with the first form. Remember, the first form says sum of products. So we have to build products first, then take summation of them. Let's build the products. We have R and S. So here, we rely on the input variables. The variables were C and M. Don't confuse it. Here we have to switch to R and S. So let's see this side. Hopefully everyone can see it here. So we will just populate all of them. RS, RS, RS. Just populate them. And then think how we could have this as a result in 1. So 0 and 0, 0, 0, 0 times 0 equals 0. Then we need to switch both of them. 0 and 1, we need to flip all the zeros into 1. So we need to flip the first one. 1 and 0, we need to flip this guy. So we need to flip here. 1 and 1, no need to flip anything, done. Okay? Now we look at the output. Where is it 1? Over here. So this would be our equation. So P is the output. And we say P equals RS. Or, remember this is sum. So we could represent it as summation equation. And then with the index of that min term, 0, 1, 2, 3. The index of this min term is 1. This is your equation. As simple as that.
You don't have to do what you did in the red right there. Can we just go straight to where it says 1 to the output?
Do you need to build this column?
Do you have to build that?
It's up to you. If you are smart, you can go directly say, oh, I know this second one is this form, and I want to write it right away. But you might make mistakes. I would prefer to write the full thing and then just take whenever it's 1. It's easy for you. Imagine for this case it was simple with a single 1. If you have 2 1s, 3 1s, 4 1s. So always do it this way and then consider which one to take. Yes, please.
And also, since it's already stated in the question, do you have to run the truth table? Because you could have just written that P equals R bar times.
Excellent. Excellent. So that's why we said we're going to solve this question in 2 ways. One of them, taking the truth table. The other one, try to extract it ourselves without building anything. From the question, sometimes it's really clear, it's real straightforward to build an equation. But I wouldn't recommend it. This is just to practice it, like, okay, let's see, verify from the logic, and then you start building the truth table and you compare the 2 methods. Okay, so far we built here, we agree on the solution, everything is good for us, okay? Now think about the question itself. Is it easy to extract that equation or not?
It's just only one thing, yeah.
And it's given to you in the question. It says only in this situation, and we have and. So we have the same condition. Both of them should apply. And even it's giving you the R bar in this case, and S, and S. So this is how we would know whether it's plus or multiplication. The question already telling you, and we have sandwiches, right? So that's why we have the dot over here. And we have the nuts. And this is how we interpret the question right away. I don't recommend using that, again, because you could interpret the question in different ways, especially if I'm not giving you those variables. I'm not stating whether it's 0 or 1. Like in here, you can really interpret it in a different way. When S equals 0, you have sandwiches. When S equals 1, you don't have sandwich. You could do that. And this would result in different equations. I would recommend you could extract this, okay, in your mind, and then compare with the result that you get, and see if it makes sense or not. Right? Now let's see another example. You'll be considered a winner W is the output if we send you $1 million for a small notepad. Okay? Would you take a notepad or $1 million?
No bad.
Who said that? Yeah, sometimes the money is ruining us. It's not good all the time. Right? So it'll be considered as a winner, means W equal 1, okay? If we send you $1 million, it means you got the $1 million equal 1, or not and, okay? Or small notepad. Now it doesn't matter if it's small or big. No, it's n. Okay, how we would do it? Do we have any zero? No, so there is no need for not. No need to negate that value. Okay, so what you would say? What's the equation would be? W equals. We have nuts? No. We have m and n, and there is or, then m or n. That would be the equation. I don't recommend you using this kind of way of solving it. I would recommend you going directly with the truth table, try to decide based on the output, do whether we have more ones or more zeros, and then decide which form you're going to use, and then use that form to build your Boolean equation. Right? You could, like, quickly, if you practice well, you could extract that equation and then use it to verify your answer. Any question? Yeah. If you don't want to go to the book, at least take those examples to practice. I don't provide the truth table for this one, but I believe straightforward for you. Okay. Let's take another example. You can eat delicious food if you make it yourself. So delicious food, it's up to you. You could use D, for example. If you make it yourself, M equals 1. Or you have a personal chef, C. Remember, there's or. A personal chef. And she or he is talented, T equals 1. And but not expensive. But not expensive. X equals 0. So X here, X means expensive. Not expensive means X equals 0. So it's not expensive. So either this condition or this condition. And for this condition to be met, 3 of them should be satisfied. 3 of them. So this, and this all together should be satisfied. So how we could interpret this as equation?
E equals m plus
E equal
m plus CTZ.
Plus, excellent. Why plus?
Because when you have the or.
Or, excellent. Whenever there's or, directly plus. And it makes sense because when substitute with logic values like 0 or 1, you will see that the or will make either this satisfied or that satisfied. Okay? And then C, T, and not X. Okay, X bar. Why X bar?
Not expensive.
Not expensive. Yeah. If it's 0, you need to negate that value. Okay. You need to flip the value into 1 from 0 to 1 using an inverter gate. Okay? Yes.
So just to be clear, the CT is together because it's stated that it's and, right?
Yes. And the but over here, we convert into and, right? And then the but not translates into not good, right? Is it clear? Not and not expensive, and not expensive, right? Now, how many input do we have in this equation? Four, right? And then you bring a very long truth table because you have 4 variables. Then you need 0, 1, 2 zeros, 2 ones, 4 zeros, 4 ones, 8 zeros, 8 ones. Okay? Yeah, please try to practice this in your own. Build the truth table out of it and try to extract the Boolean equation from it. All right? Sorry. Yeah, please add it.
I trust you.
Aaron? All right? You can enter the building. You can assume in this situation, this example, we don't have the variable. So assume it yourself. You can enter the building. You can say building or E or something like that. Okay, enter the building, E equal 1. If, so there is a condition over here. If you have a hat and the shoes, then H equal 1 and the shoes on, or if you have a hat on, then or okay. This is how we interpret it. Then how to build the equation? E equals HS plus H. Excellent. That's great. Yes, please.
This situation can it just be boiled down or reduced to each or
Excellent. We will come into that. We'll come into that. How we optimize further. Remember, as I told you, this is the first step, how you extract the equation. But then later on, we have several ways to optimize further the equation. But remember, you have to do a great job in the first step, building the equation. If you do a bad job, you'll get many terms, and then it will make difficult to optimize it. Okay, so be careful with building the truth table, extracting this equation, and then we will see later on, as your colleague said, we can further optimize this because it makes sense to have it as H only without the S. Because as you can see, which one is dominate? You can assume your own yourself. If H equals 0, what will be 0 plus 0 times anything is 0. So 0 plus 0 is 0. Then whatever H is 0, the result is 0. Now with H is 1, 1 times S always 1, because 1 dominates, right? No, sorry. Here will be S, right? H 1 times anything is S itself plus the 1. So S plus 1, then the 1 will dominate in summation, and then the result will be 1. So you'll see apparently that the output really relying on the H value, and then you can optimize this into H. But we will see this in a few seconds. Hopefully we can jump to that topic, how we can optimize those further. Right? Yeah, this is different question. Right? You can enter the building. Again, let's assume E equals 1. If directly, then there's a condition. You have a hat and choose on, then H and S equal 1 equal 1. Or if you have a hat and no shoes on, hat equal 1 and no shoes. If you get this correct, the next step will be easy. Just replace the or with the plus and the and with the dot. And if you have equal 0, directly add the not to the variable. So what would be E equals HS plus, excellent. We have a bar over there. Okay? Yes. Excellent. Yes. Boolean equation are exactly same as algebra equations. So you can use those properties that we will see in a few seconds. Okay. This will be the initial equation. You could optimize it further. We'll see that. All right. Now let's jump into that topic. Hopefully those just examples get you on track on this topic. Please try to solve them your own. Build the truth table, the complete one. Decide which form you would use and compare your answer with what we have. Now let's go with the first topic, which we call it axiom or trivials. So those are something like easy to know. Probably if you study algebra before, and hopefully all of you did, you will find those like really straightforward, really easy to come up with. So we'll use this topic to simplify Boolean equation. To make them simpler means less number of terms and less number of variables, okay? Like regular algebra, but simpler, variables have only two values, 1 or 0. And this is what we call as duality. And duality here means if you replace the dot with a plus and you replace the zeros with 1, you could directly get the opposite side of the equation. We will see this in this table. All right. So the first axiom, when b equals 0, it means it's not equal 1. And that's why we call them those as trivial. Yeah, so what? B equals 0, it means it doesn't equal 1, right? And this is important in the question itself. When they tell you there is a hat on or there is no hat on, then directly implies either 1 or 0. Cannot be both of them, okay? If the 0 doesn't, it means it's not a 1. And we have a not for the 0, then it's directly 1. When you have a 0 multiplied by 0, we consider it as 0, okay? When 1 multiplied by 1, then it's 1. When 0 multiplied by anything, directly 0. Okay, those are the trivials. So 5 trivials. Now let's see the duality. The duality, we replace any dot with a plus, and we replace the 0 or 1 with 1 or 0. This is how we come up with the duality, which is again trivial. It's easy to come up with. If b equals 0, b, it's not equal 1, right? Likewise, if we flip the 1, if b equal 1, then it means it's not equal 0. Now with 0, not, it's 1. With 1 not or bar, then 0. 0 times 0, flip the dot with the plus, So 1 plus 1, and flip the 0 with 1, 1 with 0, and then you will get 1 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1. And remember, the OR is always summation, the AND is multiplication. If you think about it this way, it's easy for you to know these things, all of them. Because always when you have 0 multiplied by anything, is directly 0. You don't have to worry about what this variable is and so on. And likewise with the summation, 1 always dominate, as we explained in the lecture before, right? Hopefully this is clear to you. Any question? That's why we call them trivial. Okay. Now let's go with theorem. Theorems are more advanced than the axiom. Theorem 1. We start getting a bit more difficult as we go with theorem. So b times 1 is directly b. So if you see in your equation, b times 1, okay, for example, this variable was all the time 1, right? So you can replace it with 1 plus ctx bar, something like that. Over here, you see if it is multiplied by 1, then it's directly b. If it is multiplied by 0, then directly 0. Doesn't matter what's the value of b, because 0 will dominate in the multiplication, and 1 will cause this one to dominate based on this value. So if this is 0, we will have 0, even if we have 1 over here. If this is 1, then we'll have 1. So apparently this can be converted into b. Now, b times b in algebra, you would say something to the power 2, right? But in Boolean, we don't have to the power 2. It's either 1 or 0. So which one you will go for? Is it 1 or 0? B times b. Now, if you are not sure, you can replace with values. And this is the safest method. Just replace with value. You would assume b, for example, 0. 0 times 0. 0. Now let's replace with 1. 1 times 1? 1. So what's the output? If the output is not one value, then you cannot replace it with one value. Then you would simply say it's equal to the input. As you can see, whatever the input is, then the output is the same value. Then b times b equal b. Okay? Always when you are confused, replace with values. Assume 0, assume 1, get the output, and then you can verify it's correct. B with 2 bars, B double bars. What is that? You can think about it as B bar, all bar again. So this will do the inverter, right? And this inverter back. So it's like input with a NOT, and then again another NOT. A NOT will cancel the NOT, and then whatever the input is, the output would be the same. Okay? So with 2 bars, it will cancel each other, and then you'll have a B. Now B multiplied by B bar, let's get it. So this is similar to this. This is similar to this, but we have a bar over there. Let's see. Now, we are not sure. Assume we are not sure about the B times B bar. Directly, when you are not sure, try to replace the B with a value. Let's assume 0. 0 times 0 bar, then equals 0 times 1. 0 times 1? 0. Okay. So if we replace B with 0, the output would be 0. Okay, let's see with 1. 1 times 1 bar equals 1 times 0, and then it's again 0. Okay, when the output is the same, then you can safely say that the output always will be 0. Because in both cases, 0, then this one, we can safely say it's 0. If it's in one case 0, in the other case 1, we cannot say it's equal 0. Okay? If the 0 here agree with the input as 0, and then here we have 1 that agree with the input as 1, then the output is B. right? But if it is the opposite, like here we have 1 and here we have 0, so 1 here is the opposite with the input, and the 0 here is opposite of the value of the input over here, right? Then this one would be B bar as out, right? But because both cases are 0, then we can replace the entire thing with a 0. This is if you don't want to remember this table, you can easily, logically solve it or come up with those theorems. Is it clear? All right. Should we move on? All right. Let's go with the duality. Duality, remember what's duality? Just replacing the dot with the plus, the 0 with 1, 1 with 0. So you'll see, replace the dot with the plus, the 1 with 0. You'll come up with those equations, and hopefully it makes sense to you. Let's see, for example, the first one, b plus 0 equals, this is algebra, right? Nothing magic over here. B plus 1, then 1 will dominate, then you have 1. B plus B equals B, right? Same story with the power 2. Here, there's no dot or plus or 0 and 1, so the duality would be exactly the same. Over here, we replace the dot with the plus, then we come up with this, B plus B bar, and then we need to have this situation replaced with B as 0, B with 1, and then see the output if it agree with the input or not. Okay? You want to do it? Let's do it together. All right, so it's B plus B bar. Now, replace with B as 0. 0 plus 0 bar equals 0 plus 1 equals algebra, right? 1 will dominate. This is 1. Remember, the B here equals 0. So this is the opposite with the input. So this is B, right? Now, we want to replace B with 1. 1 plus 1 bar equal 1 plus 0 equals 1, right? So regardless of B, sometimes 0, sometimes 1, the output is always 1. This is directly telling you that this all the time can be substituted with 1. Yes?
If you consider B as 1 and then the bar 0, you can pass B, so then instead of B, 1 plus 0.
You could do that, but this is really clear. You don't need to optimize it further, but we will see that. That's an excellent point. You can take B out, and then you can further optimize, which will be the same thing. You'll see this theory very soon, next table. Okay? Is it clear with those 5 theorems? All right. Let's go with more. I will continue with T6 until T11. So now we'll start having more variables. As we said, we'll start increasing the complexity of this. Now, B times C is the same as C times B. This sounds like, okay, so what? But this might sometimes help you to optimize further. You could switch the variable, and then you could take one of them outside, and then the rest within the parentheses, and help you to optimize further. Okay? For example, this case. So T6 will be really helpful in T7. You'll see that. So B times C, all between parentheses, times D is the same as B times C and D between parentheses. Why? Just look at this theorem. It's exactly the same thing. Now, why this could be helpful? Again, it depends on the situation or the equation or the question. It might be more helpful to take B out right? And keep C and D because you might have C and D bar somewhere, and then you could cancel them out. Okay. And when we look at the duality, so just replace the dot with a plus. There is no 0 or 1, so we cannot replace them here. So just replace with a plus. And then it's exactly the same situation. So B plus C, all parentheses, plus D is the same as B plus C and D, all in parentheses. Okay? All right. Let's go with this. Now we have a mix of a plus and a dot in the same equation. So B multiplied by C plus D is the same as if you distribute the B to the C and B to the D. So B multiplies C, all parentheses, plus B multiplies by D, all parentheses. Just distribute the multiplication with that. And this is, again, algebra. Now in here, when you switch the plus and the times into plus and the plus into dot, this is what you'll get. B plus C and D, all parentheses, is the same as if you distribute the B to the C and B to the D. And this is a bit different than what we have in algebra. We don't do that in algebra, right? Have you ever distribute a variable when there's a plus between the parentheses? We never do that, right? But we do it here in Boolean. So this is one of the exceptions that's allowed to be done in Boolean. So when there is a plus, you could distribute this variable to here and distribute it to there. But remember, you distribute also the plus sign. So the plus over here will be here and there, and then the dot will be over here. Okay? That's why we have a warning over here. This is only exists in Boolean algebra, not algebra. Have a question? Okay. All right. Now in here, it's exactly straightforward from T8. Let's see it. So B multiplied by B plus C, you can distribute this over here, right? And then you'll see that's equal B. And this is what we discussed right here. Okay? This is what your colleague suggested to optimize, I think, this equation. If you don't believe it, just try out with B and C, and you will see that's always the output equals the value that you assume for. The duality fit, B plus BC, and we agree that we can distribute this over here. So let's do this, for example, because it's a bit weird. Plus B times C. And then you distribute the B. Remember, you distribute the plus sign over here. Then you have the dot. And then you distribute the B plus C. Now, B plus D, we already have it in theorem before. B plus B is B. Excellent. Right? And then what we have over here, B plus C. What does it mean? So if you cannot optimize it further, you can directly assume here values. Let's assume values, for example. Now, either you could go further and multiply this with this, or you leave it here and then try to assume some values. So now we want to go with B and C. Let's build the whole thing. 0, 1, 0, 1, 0, 0, 1, 1. Okay? Because we have two variables. We cannot do it as simple as that, assuming one variable, right? We have two variables. So we have to be careful about this. Now this one will be B plus C. Okay? So now B is 0. So we have 0 plus C. Then the value would be C multiplied by B, and then B is 0. This will be 0. 0 in B, think the same story, because this one will be zero, right? And this will be C. And then C multiplied by 0, it's always 0. Now 1 and 0, so B is 1. Then 1 plus C is C, right? 1 plus C is 1 plus C. If C is 0, then the output is 1, right? And 1 plus C is 1. And the B is 1. So 1 times 1 is 1, right? Now 1 and 1. 1 plus 1, 1 times 1. So what do you see here? What is the pattern? The output is equivalent to B all the time. So 0 and 0, 0 and 0, 1 and 1, 1 and 1. Okay, so we can replace the whole thing with B. Is it true? Yes. Okay. Now, any questions so far? Any questions so far? Now we'll see that this is really a method for proving those theorems. So this is what we call induction. This is one of the methods to prove any of those theorems. Okay, so we have two methods to prove any of those theorems. This is one of them, which is really trying with all kinds of input. If you try with all of them, then it's 100% clear to you that this is true all the time. Now, with P10, so P times C plus B times C bar equals B. So how we would remember this theorem, this is extremely important. This is one of the most often used theorem in optimizing the equation. When there's a variable, and there is the other variable, we see the opposite of it in both sides, in two terms. One of them C, one of them C bar. So for example, if you see here A and A bar over here, it's directly taking the other variable as the output. Okay? You'll see it very often used in equation or optimizing the equation. So when there's a variable and the not of the variable in two terms, then directly do canceling them out, and then the output will be relying only on the first variable. Likewise, with the duality, just replace all the dots with the plus and the plus with the dots. You will come up with this one. Okay. Should we try it with the truth table? Yes? Okay. So we have B, C, and let's try this side to be fair. Okay. Remember, there's always one variable and the not of that variable, and there is another variable with no nuts. Okay? And it's always taking that variable, not this key. So this equals B. Now let's try it out. How many input do we have? We have B and C. We have one output, which is this guy. The whole equation is the output, right? Then 0, 1, 0, 1, 0, 0, 1, 1. Okay, let's try the first one. So 0 and 0. 0 times 0, 0, plus 0 times anything, doesn't matter this, directly 0, and this is equal 0. 0 and 1, 0 times 1, 0, plus 0, yes, 0 times anything, 0, equals 0. 1 and 0. 1 times 0, 1 times 1 equals 1. Right? 1 and 1. 1 times 1. 1 times 0. 0. And then 1 plus 0, 1. Excellent. And we will look at the output 0, 0, 1, 1, 0, 0, 1, 1. So this really equals GD. Okay. All right. Now the second one. The second one. Second one is a bit tricky. Please pay attention. B times C plus B bar times D plus C D. You can cancel out this guy over there. As simple as that. Why we do that? Why we do that?
People see it here already evaluated and
And then
You C and D cancel each other out, unless they're multiplied by 13.
now remember the pattern. Look at the pattern over here. We cancel C and D together because they are distributed with the B, right? So we have one of them here, one of them over there, and the first variable, one of them with B, one of them with B naught. Okay, so remember the pattern. Exactly same with this pattern. So you have C and C bar, but here you have B and B. And then you can replace it with one of the terms. Now, apparently, B here, if you assume it as 0, right, then you will cancel this, but you will keep that. And then if you assume it 1, you will cancel this, but you keep that. And this is telling you that the B value will dictate either C or D. And then both of them has no sense because some of them will be 1, some of them will be 0. Okay? Because the B negotiation over here. So we have the B and B bar distributed over the C and D, and then those values will have no effect except for the value over here, the B. Okay, so it really depends on the B now, but not on C and D together. So one of them will cancel one part, one of them will keep the other part, because we have B and the B opposite. Now, directly, if you don't trust it, try it out with the truth table. How many input do we have? We have B, C, and D. So we have 3 inputs. Okay? So you would try it with B, C, and D, and you would see that. Now, since we're talking about proving those, let's delay this until next lecture. This is extremely important, De Morgan theorem. But since we already talked about proving those, so we have 2 methods to prove any of those theorems. The first one, perfect induction, which is exactly the same thing you've been trying all the time, which is building truth table. But remember, that's why we call it perfect. We have to consider all kinds of input. Don't just assume 2 values or 1 value. If it is 1 variable, go with 2 values, both of them. If 2 variables, go with 4 possible options. And this way, how you build the complete truth table. The second one is to simplify the equation and try to come up using the previous theorem. For example, we saw it clearly. How we come up with T7 is based on T6. Bless you. How we come up with T7 based on T6, right? So based on that, we could simplify this equation based on this, and then we come up with this. And that's the second method to prove any of those theorems, either to build the complete truth table or use another theorem in the theorem that you're trying to invent. And I give you here a few examples. This is how we build the truth table. We already go through it many times. And then the second one, this one, how we can come up with B based on this, how we simplify this into B. You can use all the previous theorem in order to come up with this one. Okay? But the truth table is always the easiest. You don't have to think twice. You don't have to remember anything. Just directly populate all the input values, and then calculate the output right away. All right, next time we will cover De Morgan. This is one of the most important ones. So to be honest, I think starting from T9 to T12 are the most important one. And the rest, it's easy for you to come up with. I think those, you would require you to really remember them, okay? You can come up with them, but it will be easier for you to remember those 4 theorems in order to simplify an equation. All right? We'll continue next lecture. Remember, next lecture will be an assignment in class. So we'll cover lecture 7, 6, and 5. Where's the attendance sheet?
Right here.
We have a question.
Yes.
So like our next assignment would be next lecture. Gonna cover the videos that we were doing, right?
Which video?
Remember those 2 videos that we chose to look at, the previous, questions, like what was the next hour long?
Yeah, they're already on YouTube.
Okay.
Not the one before.
Okay.
Lecture 6, I think we did the mistake. We stopped the recording before we start. So we don't have a recording for it, which is the transistor for AND, gate, and so on. Yes.
Talk about the ones you gave us to watch slides.
Oh, yeah, yeah. There's 2 short videos on YouTube at the end of the lecture. Yes, yes. This is already included. Right?
What's your